Hello and welcome. Today, we're going to pull back the curtain on something that happens millions of times a second, but we never see it. We're talking about how your data actually gets from point A to point B across the internet. So let's dive right in.
Welcome to Super Courseva. Unlock the secrets of the internet and master computer networking. Let's dive in.
Just stop and think about that for a second. You hit send on an email in, say, Sydney, and moments later it pops up in Stockholm. Is it magic? Nope. It's actually a super high-speed, incredibly well-organized global relay race. And today, we're going to see exactly how that race is run.
So here's our game plan. We'll start with the big picture idea, the relay race itself. Then we're going to meet our star athlete, the router, and find out how it makes its decisions. After that, we'll get into the real nitty-gritty of the baton pass, see the race in action, and then wrap up with the key rules you need to know.
Okay, first things first. The absolute best way to wrap your head around how data moves online is to picture it as this gigantic, globe-spanning relay race.
Now, the official term for this is routing. See, your data, that email, that picture, it gets chopped up into these tiny little pieces called packets. You can think of each packet as the baton in a race. And routing? Well, that's just the process of getting that baton from the starting line all the way to the finish line across literally millions of interconnected tracks. Of course, every race needs runners, right? And in the internet's relay race, our star athlete, our MVP, is the router. This little box is the unsung hero of our entire digital world. At its heart, a router is basically just a specialized little computer. It has one job, and one job only, to grab a data packet, our baton, and intelligently pass it along to the next runner in the chain, getting it one step closer to where it needs to go. That's it. That's its whole purpose in life. And here is the absolute most fundamental thing you need to know about a router. To even be a router, a device has to have at least two connections, or what we call interfaces. You can just think of them as arms. One arm is connected to one network, and the other arm is connected to a different network. That's what lets it be the bridge, passing that baton from one racetrack to the next. So how in the world does this little runner know where to pass the baton? It's not just a wild guess. Every single router on the entire internet follows the exact same, super fast, four-step thought process.
Let's walk through its checklist. It's so simple and elegant. 1. The packet arrives. 2. The router peeks inside and looks at the final destination address. 3. It does a quick search in its internal map, which is called a routing table, to figure out the very next step on the journey. And 4. It shoves the packet out of the correct arm towards that next stop. Receive, inspect, look up, forward. And this all happens in microseconds. It's incredible.
Okay, now we're getting to what I think is the most technical, but honestly, the most brilliant part of this whole system. This is the secret sauce. This is how the handoff, the actual baton pass, really works. All right, pay close attention here, because this next concept is the absolute key to understanding how the internet works on a fundamental level. It's all about how things are addressed.
The best analogy is this. Think of your data packet as a letter. The IP address, that's written on the letter itself. It's the final ultimate destination, 123 Main Street, London. That address never ever changes during the whole trip. But that letter gets put inside an envelope. And the MAC address, that's what's written on the envelope. It's only for the very next stop, the next runner in the chain. And at every single hop, that envelope gets thrown away and a brand new one is created just for the next leg of the journey.
And this is exactly how it works, what we call the strip and repack maneuver. The router gets the envelope, it rips it open, throws it away. It looks at the letter inside just to confirm the final destination. Then it grabs a brand new envelope, addresses it to the very next router, and sends it on its way. The key takeaway, the thing you have to remember, is the letter inside is never touched, but the envelope changes at every single stop. So now that we get the handoff, let's see what this race actually looks like. From a quick sprint across the room to a full-blown global marathon. So in the simplest case, our router gets the packet, looks at its map, and realizes, hey, the finish line is on a network that I'm already connected to. This is a one-hop sprint. It just makes the final envelope and hands the packet directly to the recipient. Easy. Race over. But as you can imagine, most of the time it's a much longer race. The router looks at its map and sees the destination is far, far away. Its map doesn't know the whole path. It just knows one thing. To get there, your next step is to pass the baton to router number 2. So it does the whole strip and repack thing and sends it on. And then router 2 does the exact same thing, passing it to router 3 and on and on and on in a chain of hops. So just how many hops are we talking about in the real world? Well, for that email, going from Sydney to Stockholm, its packets are going to get passed between 10 to 20 different routers. That's 10 to 20 individual handoffs across continents, across oceans, all happening in a blink of an eye. It's just truly mind-boggling when you think about it.
All right, let's bring it all home and go over the essential rules of the race. If you remember anything from this, these are the core principles to lock in.
Okay, let's recap. Rule 1, routers are the bridges that connect different networks. Rule 2, they use routing tables as their maps to make decisions. Rule 3, this is the big one, the local MAC address, the envelope, changes at every single hop. Rule 4, the final destination IP address, the letter, always stays the same. And finally, there's a really clever little safety feature called time to live, or TTL. It's like a self-destruct counter on every packet to make sure it can't get lost and just loop around the internet forever.
So, we've seen this beautiful, elegant system for how everything works when it all goes according to plan. But that leaves us with a really fascinating question, doesn't it? What happens when a router's map is out of date, or a connection somewhere in the world suddenly breaks? Well, that's when things get even more interesting. But that's a story for another time. Thanks for watching.